Is it working? Yeah, cool. All right. Hello, everyone. Thanks for coming back after the break to watch my talk about motion control with multimodal AI. But before I get started on this, a little bit about me. I go by DevCharlie online usually. I'm a senior research engineer at CrowdStrike. That's a cybersecurity company. So what I'm going to talk about today, it is research, but it's personal research. It's not research in cybersecurity. But sometimes, when you do research, you can kind of apply the same methodologies in like the way that you're thinking about the problem, that you're testing hypotheses, and things like that. But outside of my job, I'm an author. I wrote a book about TensorFlow.js back in 2020, so it's kind of old now, but it means that I've been doing things with motion control since about 2018, so it'd be like 7 years. And I'm also a front-end master's instructor. So if any of you is like using the front-end master's platform, I gave a talk about TensorFlow.js as well there. I mean, of course. And yes, as I was introduced, I'm basically a creative technologist. And otherwise, outside of tech, I'm trying to get better at having non-tech related hobbies. So recently, I got my diving license. I'm not very good at it, but you get better by practicing. I am now a runner. I never thought I was going to be a runner, but now I run races, trying to play the drums, learning German, and I also, at the beginning of the year, I got my technician license in radio. So if you're part of the radio amateur community, it's usually old people, but anyway. So my call sign is KO6HPR. If ever there's a zombie attack and you turn on the radio and you hear KO6HPR, it's me. Anyway, okay, so let's talk about motion control. So as I said when I introduced myself, I've been doing this for a while. And at the beginning, I was using a platform that's called Teachable Machine. So it was a website built by a team at Google. And the point was to help people train or build a classification model very quickly. So you had an interface where you were turning on the webcam and you could feed it certain images with labels, and you would train a machine learning model right in the browser, export it, and being able to then add it to your apps. So I think the very first thing that I built, I called it Teachable Keyboard, not very creatively, keyboard with Teachable Machine. And very quickly, so I fed it images of me tilting my head in different directions, and then I exported the model and built an interface where basically with my head, then I was triggering that, I was turning that into commands to write something on the screen. So it's like left, right, and when my head was down, it was basically entering the letter. But after playing with this, I wanted to kind of go a little bit further. So I started then using models or machine learning models that do more specific things. So for example, here it was a facial expression model. And I don't know if any of you remember, there was like a game from many years ago called Rainbow. It was an iOS app, and you were making funny faces. And if you do a shocked face, then the emoji goes up. And if you frown, then it goes down. And you're supposed to catch the stars and avoid other emojis. But I don't have an iPhone. I'm an Android person. So I was like, I want to play as well. So I built a web version of that so that anybody with a browser could then play a clone of Rainbow. So this model here, it wasn't even TensorFlow.js, it was another one. I think it was called like Face something. It was like a random JavaScript library. But I wanted to go a little bit further again. So I moved on to more, let's say, granular model, and I started with pose detection. So if some of you have watched Squid Game on Netflix, there's this game called like red light, green light, where when the doll turns its face, you're supposed to like freeze. And then when the head is like not looking at you, you're supposed to like run and try to survive, basically. But again, I thought it would be fun because it's like, well, if you can detect different key points in your body in the browser, then you can kind of make a little game at home. And when I talk about key points, what you get when you use either MoveNet or PoseNet from TensorFlow.js is something like this, roughly. So you don't get like the green lines, but you get the red dots. And you can have, I think, 17 key points. And it's basically raw data, raw X and Y coordinates of these key points on your body. And what starts to be quite interesting is that when you have just raw coordinates, how do you define what is like not moving, right? So if I'm like this, how do you calculate that I'm not moving versus moving? We're not going to do that right now, but it's kind of like the type of thinking that gets quite interesting. But then, okay, so then I moved on, and I was like, okay, actually, no. So in the demo with the Squid Game, I was using all the key points of the body, but you can also use the same model to build, to only focus on a couple of key points. So for this one, I focused on the right wrist and the left wrist. And again, I think I like to create clones of things that exist. So there was a repo on GitHub that was a clone of Beat Saber using A-Frame. If some of you have used it before, it's like a library to do 3D in the browser. But the goal of them was to be used with WebVR. So you would connect your VR joysticks to the web, and you would be able to run that in a VR headset. But I didn't want to buy a VR headset, and I didn't have one. So I was like, I have hands, like I can play Beat Saber with my hands. So I modified the repo that I found to remove the part that was supposed to connect to joysticks, to then instead use TensorFlow.js with PostNet and focus on the coordinates of my wrist. And then you add collision detection and things like that, and you end up with a game that you can play with your hands. But then there's some models that then focus on the hands themselves. So multiple key points in the hand instead of having just one on the wrist. You have a lot of key points on the hand. And one thing that I built with this is I wanted to experiment with what would it look like to use the tools that we're using currently. So that's Figma. To build interfaces. So here in the GIF, it's just a zooming gesture, but I also experimented with having like a pinch gesture that would grab shapes and like move them around. And you get to kind of think, okay, if we were then controlling interfaces with gestures, what would that look like? And what you get when you experiment with a hand detection model specifically is that you get a lot more key points. It can be quite interesting if you're thinking, okay, when I'm thinking about a pinch gesture, again, if I only get raw coordinates of fingers, how do I define that this is a pinch? We're not going to talk about this, but this is a nice exercise. And I think the last model that I used is even more specific. It's around gaze detection. So it focuses only on a lot of different key points around the eye. And what I was building here, again, a keyboard, I don't know why. But if you only have two inputs, left and right, then how do you write something? So here the concept is like not only working on the detection with like the key points, but also how do you reinvent the keyboard interface to be able to write faster? So in the very first demo at the beginning, I was going like letter by letter to the left or right, but that ends up being very long if you're trying to go to the last letter. And here, the concept was to split the keyboard in two, and then if the letter that you want to select is in the left column, then you click left, and it kind of splits it into over time. So you end up being able to write a word pretty fast. And then I kind of moved on to be like, okay, so if you can write with your eyes, cool, but how could you code with your eyes as well? And you end up also, instead of just thinking about the detection, you also start to think about, again, if you only had left or right, how would you write code? I'm not saying like, should you, or is it possible? I'm like, how? And so you start thinking about when you write code, there's only a certain amount of things that you can do. There's a certain amount of ways that you can define a function, but you don't really necessarily do it with natural language until now, but we're not going to talk about that. It's like even if you write a prompt, like write me a function, it ends up being still code that is written in a certain way to be able to be run. So yeah, in this experiment, I still had a section with the different things that you could select, and then it was triggering snippets for React components in VS Code, and there was the live reloading. So then I was just writing a very, very small thing that was printing something on the screen. So at this point, it's like mostly models that were with TensorFlow.js, but I started to see some limits when I was working with this. So the custom detection logic needs to be implemented for each gesture. So if we're thinking about the hands, if you want to do a thumbs up and you only have raw data of X and Y coordinates, like how do you define that? How do you make sure that it's kind of like generic? So it would adapt. Let's say you were, let's say that you were defining a thumbs up with like, okay, all of the key points of the thumb have to be like, they have to do a line and they have to be 90 degrees. Like, okay, but then if I do that, you still know it's a thumbs up, but technically the angle is not 90 degrees. So when you're starting, this only for one gesture. So then if you want to have more gestures, you have to have specific custom logic for each. And if you're building an app that you want multiple people to use, it's kind of hard to be able to adapt to a lot of people. I'm not saying it's not possible, it's just more work. Detecting multi-steps gestures is difficult. So here, I'm only doing one, like thumbs up or a peace sign or something. But if you ever wanted to build something where you would need a multi-step gesture, like sign language, for example, how would you, if you get 60 frames per second, so raw coordinates, how do you define, like, okay, one gesture first, the second one? Like, I haven't done it. I'm sure it's kind of possible. But again, I was like, it's probably too hard for it to be something that people would ever either want to build or use. Then sometimes it's too sensitive. So when I was experimenting with the pinch gesture on Figma to be able to grab a shape, again, if you're thinking at pinch, you'd be like, oh, maybe the tip of my index is like above my thumb, but sometimes, it was jittery a little bit. And even though I was almost, doing a pinch, it thought it was a pinch, and then it was like grabbing the shape, even though this is not what I wanted. So, sometimes it kind of maybe there's ways around this, but to me, it was kind of like a limit that I found working on this. And finally, the coordinates are relative to the window. So if you're building something and you're in front of your webcam and you're testing it at like this distance, for example, and you're saying, if my hand is in the top right corner, trigger that functionality. If my hand is in the bottom right, trigger another one. Let's say if you want to build an application that multiple people use and they tend to like maybe test the thing a bit further away from the screen, or maybe let's say like they're a child, and when they put their hand up, it is technically the gesture that you want, but if their hand ends up being on the bottom right, then it will trigger the wrong functionality. So it's a little bit of an issue if things are, coordinates relative to the window. But this is what I kind of like stumbled upon when I was working with this. So I started wondering, can LLMs, or more like AI, multimodal AI, be used for motion control? So, now we're saying everybody should kind of like stay up to date with what's going on with AI, and I haven't necessarily been, a big fan of chatbots or something like that. So it's not the way that I get interested in keeping in touch with technology. So I was thinking, I love doing motion control stuff. Can I leverage what's already there, multimodal AI, for the same purpose? Can it maybe remove some of the limits that I've been having doing custom stuff? So the purpose of this research, I wanted to research how or if LLMs can be leveraged to create motion-controlled experiences. Okay, my goal was to control a website or IoT devices with hand movements using Gemini. The reason why I'm focusing on Gemini is honestly because it's free, and I haven't used it with other models, but because it's only personal research, I don't necessarily want to spend a lot of money. And also, if I don't spend money, it also means that people who have less than me, like students, for example, can also do these things. You don't need necessarily to have a team of researchers and super expensive hardware. So every time I do research, I kind of look around if there's existing research around this. And there are a few papers that I read, but they kind of focus on the idea of augmenting communication with, for example, future AI robots, like, for example, the humanoid robots, if we all kind of end up having this at home. When you think about communication, there's a lot of nonverbal communication. So, for example, even if I do this, I'm waving. I don't have to say I'm waving. But if you were talking to ChatGPT, but it wouldn't know if it's just text input or voice to text. Or even if I do this, like, it's kind of like a stop gesture. And I don't necessarily have to say something. And I think this research is more around this. So augmenting kind of communication systems for potentially human-robot interaction. So not entirely what I'm trying to do, but it's nice to know that other people are still experimenting with this. Okay, so just because I've been mentioning multimodal AI, in case you do not know, it's basically a machine learning system that can process multiple types of data, such as text, images, and sound. If you've been using ChatGPT, again, it's like mostly text or sometimes speech that becomes text, but now you can also feed it images or PDFs and sounds, and still have, that kind of like a nice output. Okay, so there are different approaches that I wanted to explore to be able to do this research. So first of all, I wanted to see, can I rely only on multimodal AI? So Gemini would take screenshots every second or multiple times per second, it doesn't matter, and returns its best guess for what hand gesture is executed. So my first approach would be like, no custom things. I'm just asking Gemini if it can recognize something in the screen, and from there, I will go. But then I was thinking, okay, can I rely on multimodal AI and augment it with fine-grained data from TensorFlow.js for maybe more complex interactions? And then finally, can I just like do my own thing and take screenshots from the webcam and convert it to vector embeddings and save it in my VectorDB, and then use Gemini only maybe for the text part of it, for talking to it, but maybe I don't want to send my screenshots to Gemini. So if you want maybe a more private solution and things like this, these are like the three approaches that I wanted to take. Before I do research, I always also have a few questions that I want to answer for myself. So here are a few. How many natural gestures can Gemini recognize? Can it accurately recognize custom gestures with little sample? Can it, or how could it recognize multi-step gestures? Can it work in an Electron app? I think it's like most of the demos I'm going to show today are like browser-based, but because it's JavaScript, can you build like a desktop app, or even go further and try with like MCP servers and stuff? Can it trigger multiple functions successfully? Can the logic be triggered without text or voice input? And this one, I'm probably going to explain it now so that then the demos will make sense. Ultimately, what I want to do is to be able to make certain gestures in front of the camera and not even have to say anything and trigger the logic from Gemini. It kind of works, but it kind of also does not. So for the demos that I'm gonna show today, I'm just gonna have a trigger word, and it could be anything, but for some reason I always say like now. I don't know, as I show, I'm like now. So you're gonna hear me say now a lot. But yeah, the whole point in the end would be like I wouldn't have to say now. It would just be like checking regularly the images, and when it sees I'm doing a gesture, it would then trigger something. Then finally, it's like how accurate is it? And that's going to be interesting to see if the demos work or not. Okay, so first, let's just check the gesture detection. So, okay, maybe the code is a little bit small. I'm going to explain all the code that I'm going to go through. And obviously, this is like a small sample because the app is, all of my experiments is a mess and it's a lot. But first of all, I'm using the Gemini 2.0 Flash experimental model. I think it's kind of an old one now. Old, a few months old. I think that they released a new one that I haven't tried. So maybe it would be also interesting to see like if the demos don't work today, if I update the model, would it then work? Then usually you define response modalities. So if you want the model to reply to you in like voice, or if you only want to reply via text. So just for the purpose of this demo as well, I have audio so that people can, if you can't read, people can hear what the model is going to tell me. But the most important part is the system's instructions. So here, my very first prompt, kind of simple. I'm telling it, you are my helpful assistant, and looking only at the hand in the stream from the webcam, make your best guess about what the gesture means. Don't ask for additional information, just make your best judgment. Okay, demo 1. So here, let me see if I have to zoom in or not. It doesn't really, maybe I do. Wait. I should have probably also specified that I start from an open source repo that GitHub put together to show how to implement the multimodal live API. They just kind of made it easy, and then I'm adding my own logic. So what I'm going to need you to focus on is this column on the left here. So I'm going to explain to you before I do it, because once I start, the model is going to listen to me and it's going to reply, and we don't want that. So there's going to be a camera here in the middle, and I'm going to make a gesture. I'm going to say now. And here on the left, you're going to kind of see the logic that the model is taking, and you should see the name of the gesture that is kind of like trying to, or that it thinks I'm doing. So I'm going to put that back. Okay. Now. Okay. Now. Victory? Not yet. Wait. Okay. Now. Yeah. Okay. Cool. And if I do now, cannot classify. What? Now. Victory. Yeah. Okay. Cool. So it kind of worked. So all right. So now we can see. Oh, thank you. Okay. So now we can see that there are. Oh, sorry. Now we can see that there are some gestures that it can recognize on its own. I didn't write any custom logic. I just told the model, hey, I'm giving you images. Tell me what you see. But it's not really interesting that way, right? What we want is to be able to call functions when I'm doing things. So that's called function calling. And what you have to do at first, you have to write some function declaration, which is basically a schema of how your function is going to work. And here I have a name. I'm going to say toggle light. That's going to be the name of my function. And I'm going to define that it receives a parameter. That's an object. And the properties, I'm going to have a property called on. And I'm saying it's a type Boolean. And the description of it is the light state as a Boolean, and I'm making it required. So every time that Gemini is going to toggle the light on, it should have an on property that is either true or false. And then that's like the rest of the function is pretty generic. It's an API. So these lights are called LifeX lights or LifeX. And here you can see that command.on, so it's going to be what I'm receiving. If on is true, then I'm sending a power on, otherwise off, and the brightness, whatever. And here is just the API endpoint that I'm sending the data to with the token. So this is more kind of classic frontend. But one important thing here is I have to update my system instruction, right? Because now I'm kind of adding a little step. So I'm still saying, make your best guess about what the gesture means, but then I say, and call the toggle light function provided. I do not tell it necessarily that to call it with on or true or false. I just say, call the toggle light function provided, and it's going to use the function declaration schema to then understand what it should do. And I'm passing the declaration in the tools section at the bottom. Okay, so let me just have a sip. Okay. This is where it's going to start to become a little bit more risky. So let me just, okay. So I'm going to do the same thing as I did. I'm going to turn the camera on. I'm going to do probably thumbs up, thumbs down. And let's see if it does what I want it to do. Now, all right. Woo. Okay. So what was interesting as well is that basically it looked at the gesture. It said thumbs up. Thumbs up is usually kind of positive. So then it decides that the value is true. When I do thumbs down, it's kind of, usually it's kind of negative, like, boo. So it understands that the value should be false. So this is kind of cool. I didn't really have to say you only have access to thumbs up, thumbs down, whatever. It just sees the gesture and then decides if it should be true or false. Okay. So, but what if I have multiple lights? At home, you don't only have one light, hopefully. But what do you do then if you have multiple lights? Because how do you know which light to turn on or off? So this is where we go to multi-turn function calling. Recently, I've seen it called compositional function calling. I don't know if they're exactly the same thing or if maybe I read it wrong. But it's basically being able to call multiple functions and let the model decide potentially which one to call first, or how it relates, how the two functions relate to each other, or what they return then relates to the second function. So to start, we have to update our function declaration because now toggle light will need a light ID. Right? We have on, true or false, but now it's like, okay, which one, And here I am saying that the light ID is going to be a number, and the description, I don't really know if it matters, but yeah, the ID of the light toggle that is returned by the getLight function. And I'm adding a new function declaration for a function called getLight. And here I have a property called detail that's going to be a string. And my description is the detail about the light, and usually a position. And the reason I did this is because usually we think, oh, well, you're going to give it an ID, like a number, a UID. But as a user, I don't remember the ID of my lights, right? So I'm not going to say, even if I was talking to the AI, I wouldn't say turn light like 43AFB, right? So at home, I have 2 Philips Hue lights. Obviously, I can't travel with them because you need like the bridge, so I bought these. And I have 2 lights under my TV, one on the right, one on the left. So what I want to be able to do is I could talk to the model and say turn the right light on or turn the left light on, and then it will figure out which light to turn on because I named these lights right light and left light. So there's, so that's why I usually said a position. If you were trying to trigger lights in different rooms, then you could do the same as well, like turn in the living room and it will figure it out. So we update the prompt again, and I say, okay, so this is where it's going to start to not work as much as I would like, but let's see. So I'm saying look at which hand is making a gesture, right or left. Call the function getLight provided with the correct hand position. So it should call getLight with the strings right or left, and then make your best guess about if the gesture means light on or off, and call toggle light. Okay. Okay, I'm going to go briefly to this again. If you can't read the code, doesn't really matter. I'm sure you will be able to implement this. But using the open source repo that's on GitHub, they have like a use live API context to get the client, and the client is basically the multimodal AI API client. And there's an event listener on tool calls. So when Gemini is kind of like calling different functions, then it triggers our function here. And our two available functions right now are getLight and toggleLight. It's just kind of a mapping. So we're going to start by looking at the function calls. So Gemini is going to return the functions that it thinks I'm going to have to run, or it's going to have to run. Here, I'm storing the response parts in an array because getLight is returning an ID that then it has to pass to the next function. So here we're looping through the function calls. It should be going getLight and then toggleLight. So at first we're kind of destructuring and we are extracting the name of the function that it should call. We're kind of like calling it with the arguments. And then we're pushing the response from that call to the response parts, and then we're sending that back for another loop, right? So again, the response of the getLight should be an ID, and it will take that ID and send it to toggleLight also with the on property that it should be sending. Okay. So I'm expecting this one to fail, but it's okay. And the reason is, and I think it's actually quite interesting to be looking at things that I thought were kind of like basic, but it's not really good at. So what I'm going to do is I'm going to point with my right hand, and I would like it to turn on the right light, and then the left light, but it seems to confuse right and left quite often. So let's see if it works. Now, so it see.
My apologies.
Okay, maybe I'll try. It's getting confused, very confused. Okay, first of all, I think I pointed with my right hand, and the very first call, oh my God, it's making a lot of things up, said left. So I don't know if it's because the stream is like not mirrored or mirrored, but yeah, and here light ID 0, there is no light with ID 0. So I'm gonna try again, but yeah, this is where it's surprisingly weird that it can't recognize right from left. Now,
I apologize, but there seems to have
So
been an error converting the light ID to the correct format.
know.
I will try again. Okay, I think I got it this time. I've turned the light on based on your
Okay.
right hand gesture.
Okay, so again, I think that I was pointing definitely with the other hand and it turned the right one instead. So this is one of the ways where, sometimes I think you really see when you play with multimodal AI how it can like hallucinate things. And sometimes when you get text back from ChatGPT, you might not see that it's not real. But when you play with this, you realize sometimes it does make up light IDs that don't exist, even though it's calling getLight. So it is looping through my lights and it's returning an ID. But then for some reason, it's calling the other function with an ID that doesn't actually exist. So I'm just going to do something quickly. Turn the right light off.
Okay, I've turned on the right light.
All right, so this is not what I wanted, but you can see how sometimes it tells me it's turned it off, and it actually has not at all. So I'm going to do it myself. Okay, cool. I'm just trying to get back to like a proper state. Okay, and then I think after that, I wanted to show briefly in my questions originally that I was asking myself is like how, if I give it new gestures that it doesn't know, so not a thumbs up, not a thumbs down, and I tell it, okay, I think when I was trying earlier, when I was rehearsing, I think a pinch, it doesn't recognize what it is. So what I'm going to do is I'm going to say, okay, when I do a pinch, turn the light off. And then I'm going to try to turn it on, and I'm going to do the pinch again, and it should turn it off with giving it only one sample. So let's see. When I do this, turn the light off.
Okay, I've turned the light off.
Well, not yet, but now.
Okay, what can I help you with?
Now.
Okay, I've turned the light on.
Now. Okay, it did it, so I'm gonna like stop. So okay, so I turned the right on. The right one. Woo. My demos are actually getting worse, so I'm like my stress level is okay. So here it's like a difference between what I was telling before about TensorFlow.js, where, or even with Teachable Machine at the beginning, where you have to record a lot of samples and things like that. Here, obviously, if I refresh, it's gonna forget it, but you could see, if later on you can keep certain memory, or, later on, if you create your own, then you can possibly only do like one sample and it would kind of like remember it. So that's pretty cool. Okay, but now I want to move on to the more exciting, but also more likely to not work thing. So to mix Gemini with TensorFlow.js. So here, if we only rely on Gemini, we kind of have maybe like trigger gestures, like up or down. But what if you wanted maybe something that would require more of the different key points? So the idea for this particular section will be to point at a light, and it should turn the light on to start with. Then I have a trigger gesture that's like this to change the color. And then I'm using well, let me show you the code and then it makes sense. So when you start with importing, like for TensorFlow.js, you have to import the model and the TensorFlow.js core library. And here we're going to use the media pipe hands model. And you have to create what's called they call it a detector, but it's basically then you call detector.estimate hands. So it's going to try to find hands in the video feed. And you can then extract the different key points. So here I am extracting pinky finger tip and thumb tip, right? So I'm not necessarily I'm not showing you the rest of the logic because it's not necessarily AI related, but I have some calculation that looks at the angle between, let's say, like a horizontal line and an imaginary line between my thumb and my pinky. So that then when I rotate like this, I basically have 180, and I multiply by 2 and I change the hue of the light. So what should happen later, point at light, turn it on, trigger, set color, and then I do this and it changes the color. Okay, but what we have to do is update the prompt again. So we still have our look at the gesture, left or right, it gets the light, call the toggle light, but then if the user is making a palm gesture, call the set color function provided. Okay, I really want this one to work because it's like my favorite. But at least because it's JavaScript, if it doesn't work the first time, I just refresh and we try again. Okay, so I'm just gonna open because I need to see, I'm gonna see faster if it's not working from here. Okay. Now,
Okay. Is there anything else I can help?
now,
All right. Anything else?
oh my God. Okay. Whee!
Is there anything else?
I didn't even have to try again. Oh my God. Okay. So it worked, but yeah, so it's like, okay, I experimented, can I mix Gemini with TensorFlow.js? The answer is yes. And okay, then I'm probably out of time as well anyway, but the other idea would be like, can I DIY it with Vector DB? So I don't have a demo for that one. I mean, I did have a demo, but it's just not working, so I decided to cut it. But I'm going to talk about the way that I would have implemented it. So using DataStax, which is a vector DB, here, if I just zoom in, I had recorded before 3 different gestures. And you can see the only thing that is stored is vector embeddings. So what I had done is I had a web app that I was taking pictures from, and it was on the client converting an image to vector embeddings and only storing that in the database. So then let's say you get hacked, you can't really reconstruct an image from vector embeddings. So even if someone had access to all of the images of you in your living room or something, they wouldn't be able to actually see anything. And then I have a description of different gestures. For example, I had gesture with the palm of the hand. I think that would be like a stop. And then I think I had a victory or peace and like a thumbs up. And the idea in the end would be able to, instead of giving the images to Gemini, I would have maybe a set interval that looks at images, checks if I have something similar in my vector database, and then only give the description to Gemini, so that then it would trigger different function calls. But then it means that if you, for example, when I've been training all of this with Gemini, I have no idea where my images go. I don't know if Google stores images of me in my living room, or if it only stores vector embeddings as well. So if you want to think a little bit about privacy, that's definitely kind of I would feel more comfortable doing it that way. And then it means that you also have memory of new gestures that you trained, because they would be stored in your own vector DB. Okay, but okay, now that I've experimented with all of this, there's actually a lot more, but I had to I'll cut it short. Can Gemini recognize gestures? Yes. How many natural gestures can Gemini recognize? I didn't try it. I mean, it's only my imagination. Maybe there's others, but there was thumbs up, down, peace sign, stop. And when you do that, it's call me. It just comes back with call me. It's kind of cool. Can it accurately recognize custom gestures with a low sample? Yes. Can it, or how could it recognize multi-steps gestures? I haven't actually worked on that one yet. Can it work in an Electron app? Yes, I haven't showed it here, but it's JavaScript. So if you didn't want something in the browser, you wanted to do a desktop app that would then interact with other things, that definitely works. Can it trigger multiple functions successfully? Yes, we had getLight and toggleLight. How can the logic be triggered without text or voice input? I didn't show it because it does become buggy, but at some point what I was doing is, instead of saying now, I was programmatically sending a prompt. So every, second, I was sending a string that said what is the gesture? And I was trying to trigger then the logic, but turns out that it gets very kind of confused. So I'm hoping that maybe in the future we can trigger stuff without necessarily having to talk to it. And how accurate is it? It depends what you're trying to do. So I'm not necessarily quite sure yet. Hopefully, as the models get better, it means that maybe we'll recognize right from left better. But I have a few resources that I wanted to share. So I'm planning on writing a blog post about this. It's just because it's ongoing. I haven't done it yet. But if you are interested, I will probably share it on my website. I have not posted the repo on GitHub yet. It's a mess. So I need to clean up stuff before I do that. And I shared a link of the few different papers. And at the end is the Gemini Live API web console repo. So it's the starter repo that I started with. The UI will be the same, and then you kind of can experiment by adding things as well. But basically, that was kind of it. So the whole point in the end, the reason why I'm doing this is that I would love for people who are not engineers to be able to kind of define the way that they want to interact with different functions. If you buy a product, I don't want to have to download an app that tells me that I can only do a thumbs up or down, or I want to be able to say, well, I don't want to do that. Maybe I want this gesture to do something, or maybe I want to dance to trigger my lights. And I want to be able to just provide this functionality, but then have a create something where people don't have to know how to code to be able to set up their IoT system. But anyway, I hope that in the future actually gets better as the models get better. And who knows, maybe that's actually, I don't know, will be available at some point. But in the meantime, it's super interesting for me to research that. And it's for me, it's been a very entertaining way to learn about AI and also kind of do fun stuff and keep going in my research of motion control. But anyway, thank you so much for listening to me for the past 40 minutes.